Okay, this is video 2 from chapter 7. It's going to be about similar figures and identifying similarity. So we want to start out by discussing the difference between similar polygons and congruent polygons. So we talked about congruent polygons back in earlier chapters, and that was congruent meant they had the same size, same shape. Similar polygons are polygons that have polygons with the same shape but not the same size. Okay? So the way we tell similarity compared to congruency, everything was the same. All the angles were the same, all the sides were the same, everything was congruent to everything else. In similar polygons, the angles will all be the same. So if we look at our two figures we got here, we got two pentagons here. The angles will all match up to something. Let's do this. So the angles in each figure will all match up. So you notice we have 1, A and F match up, B and G match up, H and C match up, I and D match up, E and J match up. So all the angles in one figure will be congruent to all the angles in another figure. So that has to be the first part for similar polygons. The second thing is that the sides have to be proportional. So we talked about in video 1 about what it meant to be a proportion. So the ratios of the sides will all be the same. Okay, so in this example here, we'll have AB over FG has to be equal to BC over GH, which is equal to DC over IH, which is equal to ED over JI, and then AE over FJ. Okay? All of those ratios have to be the same. So the ratio of this side to this side has to be the same as the ratio of this side to this side, ratio of this side to this side, so on and so forth, all the way around the figure. Those ratios, those fractions have to be the same. If those fractions are not the same, then you don't have similar polygons. Even if the angles are all the same, if the sides don't have the same ratio, then you do not have similar figures. Okay? Now, if that's all true, if we have all of those things and we have all these congruent angles, so angle F was congruent to angle A, angle G was congruent to angle B, angle H was congruent to angle C, angle I was congruent to angle D, angle J was congruent to angle E. So we got all these angles that are congruent. We have all those sides that are proportional. Then we can make a statement about similarity. Now, when we name the similar polygons, the idea or the concept we talked about with congruent polygons, where we have to line the letters up the same, is true for similar polygons also. So if I say, figure A, B, C, D, E is E is similar. So similar is just one wavy line, no equal sign, just a wavy line. Okay? If this figure is similar to this figure, I got to make sure I line the corresponding parts up the same. So if I set these, angles here congruent to each other, I have to match the letters up. So if F and A are congruent, that means if A comes first, and that means in the second one, F has to come first. B and G, so G has to come second. C and H, so H has to come next. D and I is next. E and J would be last. So you got to make sure you line up the corresponding parts when you're naming these similar polygons. Okay? So that's that first part. The next thing we want to talk about is called a scale factor. Okay, a scale factor. And a scale factor is just the ratio of lengths of corresponding parts. So it's a ratio of corresponding parts or let's say corresponding lengths in two figures. Okay? Corresponding ratio of corresponding lengths in two figures. Okay? So for example, if I have two triangles, like there, and I say that these two triangles are similar, so we have triangle ABC is similar to triangle YXZ, okay? And I said, what is the scale factor okay? So I'm already telling you that these are similar figures. I'm already telling you that, okay? If they're similar figures, then they have to have a scale factor. They have to have a ratio, a common ratio between the two figures, okay? So the way we find that is by just taking the corresponding parts. In this case, we've only got two numbers. We just got to make sure that they correspond to each other. So we look at our similarity statement. They gave me AB and YX. Do those match up, okay? So AB is here, AB is here, YX is here. Notice they're in the same position in both statements. Therefore, they are corresponding parts. So I can make the scale factor so we can put it either way, just depends on how we want to say the ratio. It's either 6/3. Okay, it's either 6/3 if that's the case, if it's triangle ABC to triangle YXZ, okay, or it could be 3/6. Okay, so or 3/6 if it's triangle YX to triangle ABC. So depending what order it asks you to put them in. Okay, so in the problem, if it's asking you for a scale factor, it'll say, what's the scale factor of triangle whatever, 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 to triangle whatever, whatever, whatever. So look at the statement. That's the order that we're going to put things in. Whatever comes first goes on top. We talked about this yesterday, or not yesterday, but in the first video. When you're writing a ratio, whatever comes first in that statement, triangle ABC to triangle YXZ, that's the number that goes on top. Whatever comes second is the number that goes on the bottom. Okay? So that's how we find a scale factor. All right, so on your homework, or on a test, it'll say, determine whether these triangles are similar. So you're going to use that first concept we talked about here. You got to look at the angles. Are all the angles congruent? And are all the ratios the same? If that's true, then those figures are similar. Then it'll ask you, if they are similar, what's the similarity statement and what is the scale factor? Okay? Let's look at an example here real quick. So if I had a couple pictures here. This is NQP. And we got RST. 15. We got 12, 10, and 8.2. Okay? So we want to know, are these similar figures? And then if they are, what's the scale factor? Okay? So we got some markings in here. Let me don't forget those. So we've got N, R, we've got Q, and S. Okay? Well, to decide if they're similar, first we got to do is ask, are the angles all congruent? Okay, so we've got N is congruent to R, Q is congruent to S, and even though T is not marked, if two, remember we talked about this in way back in earlier chapters, that if two angles in one were congruent to two angles in another, we had the third angle theorem that said that the third angle in both triangles then have to be the same. So we want to go ahead and list those. All right, so we can say that angle N is congruent to angle R. We can say angle Q is congruent to angle S. Angle T is congruent to angle P. That's okay. All right, so the angles all work. Now we got to check all the ratios. So we want to look at ratios. So let's start with the smallest. So the smallest side over here is 11.5. So 11.5 over 9.2 has to be equal to, what's the next one? 12.5 over 10 and 15 over 12. So if we divide those all out, okay, if we divide those all out, you get 1.25, 1.25, 1.25. Okay, for the fractions, which means that they work. That means our scale factor, okay, is, if we would just reduce it to a ratio, the 15 over 12 reduces easily to 5 over 4. Okay, 5 over 4. So we want to make our similarity statement. So triangle NQP is similar to triangle RST. The scale factor then is 5 over 4, or 1.25. Okay, that's our scale factor. So this is the answer we're looking for. So are they similar? Yes. All the angles are the same. They all have the same ratios. So we can make this similarity statement here. Okay, once we make that similarity statement, then we also want to be able to write down what the scale factor is. Okay? All right, that's it for this video. Make sure you're getting your homework done. Good luck.